Thank you for coming to this talk. So this talk is about unpacking the Sherman real-time animation project. My name is Yifei. I'm the lead field engineer for Southeast Asia. So to give you a little bit of the project background, we have set up a Unity innovation team, and the first project that the team worked on was Baymax Dreams. It was a collaboration with Disney Animation Television to produce 3 episodes based on the Baymax IP. If you haven't seen it, I encourage you to check it out on our YouTube channel. He has won an Emmy for it. And it's a small core team. So the challenge for this new project was R&D on fur, because fur, as you know it, doing fur in real time is very challenging. So before I continue on, just to give you more context of what I'm talking about, I'll show you the Sherman Shot. I guess I have to hit play. All right. Can we? Cool. So it's easy to forget sometimes that when you see something like this, that what you saw was rendered in real time, just like the Heretic, Adam, Book of the Dead, Sherman, right? These are all rendered in real time. So fun fact, Sherman is the name of the yellow bird. It's not the raccoon. So what are the tools that we use to produce this proof point to show that Unity can be used for serialized TV shows, for cartoons, for example? So Timeline was used. Timeline is our sequencing tool, allows you to sequence camera animations or character animations or lighting and effects, and even use Timeline to control other Timeline tracks. And Cine Machine was also a big part of this, and Cine Machine is our smart camera system, allows you to tell the camera your intention, what do you want to focus on, and how would you want it to behave. It's like your own crew of cameramen. Post-processing stack, of course. This is very important to add like a quick post-process effect in real time in the engine. And a lot of effects that you saw on the shot was For example, the motion blur was done in post-processing. HDRP, so this was produced in HDRP, high definition render pipeline. And I'll talk about this a lot later, but there's a lot of squash and stretch animation in the character. You may not have noticed it, but to exaggerate the character's motion, there's a lot of squash and stretch, right? And it's difficult to create this kind of animation with simple FBX or simple skeletal-based rigs. So instead, we use Alembic Cache, and we have an Alembic Cache plugin that you can export out Alembic Cache and import to Unity. And we use shader graph to create custom shaders, and the recorder to record and output the final shot into a video format. And it can be exported out as image sequence too, and then you can then put in your favorite post software to then combine them and produce a final shot. And of course, the visual effects graph. Ashley, before this talk, was sharing how visual effects graph can be easily used to create very impressive looking effects. I'll be sharing later on how some of these effects that you saw in the shot was produced with visual effects graph. So the intention of the project is to push HDRP as far as possible. And one of the challenges here is real-time fur. So we're trying to achieve offline render quality fur in real time. And as far as I can tell, it looks pretty good. And it's very near offline render quality. And hang on. OK. I'm just checking if right, sorry about that. I'm just checking if I'm showing the right slides here. OK, sorry. And all these tools are available via Package Manager. And we also release a film toolbox package manager that includes a lot of very nice and useful tools, which I'll show you in a bit. So the whole idea of fur in real time, Marzar Animation Planet to produce this shot. It's with Unity Japan called the GIF. And this doll here, the blue color doll here that you see, has fur. So this was in 2017 or 2016, so quite a while ago. And the fur looks pretty good in this shot. And the whole idea of the fur in Sherman is actually based off of that idea from Marzar. So I'll start to share a little bit of the whole process of how Sherman was produced. So first, blocking was done, like the shot before you start actually animating. There was a blocking shot. So this was the team. The team actually did the rough layout in Maya and then imported it to Unity. But you can also do layout in Unity, which I'll show you later. In fact, now. All right, so the Sherman project is actually available for download if you want to give it a try, and contains a lot of very nice workflow tool. So I was talking about package manager, and then there's this film and TV toolbox. So this is on the package manager, contains a lot of very useful tools. So this is Project Sherman, and when you open up the project, there's this new tool menu here, and you can see under toolbars, you have this option to load a film layout, because right now this is the default Unity layout. You have your scene view, your game view over here, hierarchy, project, and so on, right? But if you switch to a film layout, this will look very familiar to creators using like After Effects or any of the video editing software. It's a more familiar layout. So there's some shortcut buttons here. For example, I can load the look depth, which is this one here, and I can load the master timeline. And this was what the artist used to create a look depth video to make sure that the lighting and the look of or the shaders or the look of the characters matches what the director wanted. And this is the Maya blocking scene. So looks like this, right? Simple blocking animation to try to get the timing right. Because once you have the timing right, you have your camera angle right, then the animator can start animating to your cameras and respecting the shot timing, right? So this was done in Maya, the blocking was done in Maya, but you can do the same with Unity. So this is the Unity blocking scene. So there's this very useful tool called, it's also on the package manager, called Pro Builder. Pro Builder, this guy. So you can use Pro Builder to create simple geometry, and that allows you to create like a simple layout in the scene. And then using timeline, you can animate these geometry or meshes, so you get your timing here. And what's interesting is Cine Machine. So if I open up this one, okay, so you can see here, let me drag it up. So there's a timeline for the cameras. There's a timeline for the animations. So like the Raccoon and the water sprinkler. And in my camera timeline, I have a couple of Cine Machine cameras. So this is one. There's a couple. So this is one shot, another shot, and so on, right? So like I mentioned, Cine Machine is a smart camera system. You can tell it your intention. So for example, maybe this shot here, instead of just a static camera, maybe I want the camera to say focus on the raccoon, right? So for this particular one, I have the cameras here. This is this camera, and right now there isn't anything set for follow and look at. That means the camera is just static, stationary. But I can tell it to say, hey, follow this guy or look at this thing, right? So here I can say, okay, I want you to look at the raccoon. So maybe go look for my raccoon. Raccoon over here, this guy, okay? So I want my camera to look at the raccoon, okay? So now it's like that, and when you see the camera shot now, it looks like that, right? It's following or looking at the raccoon. So now whenever you try to, let's say the director wanted something some extra animation on the raccoon here, maybe like instead of just moving towards the food here, he would do like a jump or something, right? And you can see the camera is still smart enough to continue tracking your target. And there's also you can specify like some behaviors on the smart camera. For example, you can give it some noise. So here I can create like some basic handheld. If you imagine someone holding a camera, right, a handheld camera kind of noise, so it's not stable, so you have some movements there, right? So there are some presets one that you can use, or you can define your own. So let's say I want like a handheld on tele lens, right, and strong like noise. So then you get like some noise over here. You can adjust the amplitude, say let's say 10 to make it obvious, right, and frequency 10, right? So like an earthquake, but no, that's not my intention, so you can tone it down or something, right? So try to simulate that organic feel like of an operator holding a camera and shooting this shot here. And for the animation, in timeline, for all animation tracks, there's this red little button on the track here. This red little button is actually your record button. So if you hit record here, you can start recording animations for the object that you are animating. So in this case, this is the raccoon. So let's say in this shot here, I want to animate him. So I start recording. Where's my raccoon? Okay, he's over here. Okay, so let's say instead of here, maybe have him appear somewhere here, and then over here, I'll have him like jump up or something. And then over here, move him back or something. And stop recording, right? So I have a recorded track. And in the recorded track, I can adjust my keys here, or I can view this track here as graphs, like that, and I can start adjusting these things here. Right. All right, so cool. Back to the slides. So we're inspired by the high fur quality bar set by DreamWorks. If you've seen these shots, Bilby by Disneyland commercial, that's the kind of fur that we are trying to achieve. So as you saw just now in the demo project, you can preview how something looks like in high definition render pipeline, HDRP. So you don't have to wait for like long render time, send it for director for approval. And the best of all, you can see things in context, which means, let's say the artist created the raccoon, right? And you're doing a turntable. But the raccoon is not in the environment of the story, or is not in the lighting of the story, right? Of course, you can create a turntable with that environment and with the kind of lighting, but what about like other shots with different lighting or different sets? Then you have to create a lot of turntables. But here, everything is real time. The director can say, okay, I want to see this raccoon in this set. I'll load this set with this lighting. Or I want to switch out the set with a different set and different lighting condition. You can see it right away. So everything is real time, and really, it cuts down on a lot of the, it shortens your iteration time. You don't have to spend a lot of time waiting back and forth. And a lot of this waiting will affect your creative flow, right? You don't want to make some change, wait for maybe a few hours before you can see the change. You want to see it instantly, so it doesn't block your creative flow. Like you can just freely experiment as much as you like. And for the project, so the characters are modeled in Maya or Max, and then we use Substance Painter for some of the PBR materials. And some of the environments was reused from Book of the Dead. Develop detail. Yeah, so like I mentioned, look depth in HDRP. So you can apply final look quality in your look depth, so you know exactly how it will look like with the kind of post-processing that you want, the kind of camera settings that you want, the kind of depth of field, right? The kind of lighting, so you don't have to wait for renders. So here's another example of how look depth turntable looks like. So the entire project, there's only one modeler, Steven. So he did all the models for the project. And like I mentioned earlier, camera layout was done with Cine Machine, and you can quickly block out a shot using Cine Machine. Even complex shots, all you have to do is just say, hey, camera, I want to look at this thing, or I want to follow this thing, give yourself some buffer frames, right? And then you can just block out all these shots, and finally export this camera animation out as FBX and put it back to your favorite DCC for the animators to use as your camera and then animate. So as you saw just now in the demo project, you can have a lot of different Cine Machine cameras. You can blend between camera shots, or you can specify how, maybe add like a procedural noise to it. And finally, like I mentioned earlier in the introduction, we use Alembic cache for the raccoon animation because there's a lot of detailing or squash and stretch, things like squash and stretch. It's not easily modeled or animated with skeletal mesh. And at the time of the project, there's a limit to FBX, so skin weighting is limited to only 4 bones maximum. But in 2019.1, we've now increased that to 256 bones per vertex. But at the time, it was only 4, so it wasn't enough for the kind of fidelity that the team wanted to create. So we went with Alembic cache. So here's an example of what I mean by squash and stretched. So if you look at this Raccoon animation here, so when it's slowed down, you can see like his body is stretched like unnaturally, right? But that exaggerates the motion to give a better sense of motion to the viewer. So you can see here like it's stretched like unnaturally, but it's essential to give that feeling that there's a lot of movements going on. So to create something like this is difficult with a skeletal mesh. And if you want to create something like this, then there's also potentially a lot of modifiers that you put on the rig to create something like this. And not all these are supported when you import to Unity. So then it's easier to just export them out as an Alembic. But of course, there are challenges when you use Alembic cache, because every frame of the animation is baked out. That means your file size of an Alembic cache is very big, very huge. And the materials from your mesh doesn't automatically map to the Alembic cache. You have to then manually map them, but the team created a tool to automatically map the materials to the Alembic cache. Yeah, like I mentioned, material management. So materials are not stored in the export, so you have to manually reassign them. But we wrote a simple tool to simplify that, and that tool is available in that Film TV Toolbox package that I mentioned earlier in Package Manager. USD, I'm not talking about US dollar, but Universal Scene Descriptor. Pixar is the one spearheading this, and it's an open source format. So it's gaining traction among studios, and I'm also very excited for USD. With USD, you can do a lot more, and you can also do what Alembic cache doesn't allow you to do. So we have a support for USD, and the first version is also available on the Package Manager. So one of the cool things with USD is you don't have to have your assets imported to the Unity project. It can be on a different location, and as you need it, you load it into the project. So that means your Unity project can be smaller and lighter, unlike importing Alembic cache, where it can bloat up your project very fast. So with USD, you're just loading from a different location. So this could be a shared location that everyone access, so you can just load that in. So lighting will be a very important component to create that look for the project, right? And we have a lighting supervisor working on this, Jean-Philippe. So everything is real time. There are some baked element, but most of them is real time. And we worked in linear color space to get the most correct look. And we use a lot of light probes and reflection probes, shadow maps, and baked GI. So not everything is baked. So things that are not baked, we use light probes to approximate or blend in that object to the environment. So baked GI looks like this. So this is mainly baked for static objects that don't move, and to try to get some of the nice global illumination onto the scene. And we've put like an array of light probes. So these are for objects that are not baked, for objects that are moving, or for objects that are maybe small and it's not crucial to affect like the overall GI. So they are lit by light probes. And an interesting thing to note is we don't bake direct lights, but we're baking indirect light. So the sunlight is not actually baked. We're only baking the bounce light of the sunlight. So you can still do things like this. Right? You can still change the lighting direction. Everything still works. We're just baking the indirect light. and reflections. So two types of reflections was used in for example, like the dish bowl here. A spherical reflection probe was used because it approximates the shape more accurately. But something like this one here, like the bloating water pipe, that was using a planar real-time reflection probe because it's more of it approximate more of a flat surface. So a planar real-time reflection probe was used, and you can see the difference here with and without. So without, you're not reflecting the raccoon onto the surface, but with, you can reflect the raccoon and the trees at the background to the surface. And the lights. So like I mentioned, after setting up the probes and baking the GI, right, lightings are all dynamic. That means you can freely change the lighting angle, the lighting intensity, color as you like. And this allows faster iteration. You don't have to wait for render. You can freely experiment how you would like the lighting to look. And nested prefab was used also because then everyone can work on their own prefab without having to break other artists' work. And this is also very interesting. You may think that the whole scene is only lit with one kind of light. For example, the sun direction is always fixed. It's not true. If you look at this video here, as you progress in the shot, the lighting condition changes. So you have Pershot lighting. So for example, like some shots, you see the tree shadow changing, right? So you can freely change your lighting based on the kind of shot, the exact shot, and you can just change it however you like. So you don't have to fix sun direction to just, okay, that's the sun, so it has to be always this direction. That's not true. You can freely change it, so you have per shot lighting. And you can see also the raccoon was running towards the dish bowl, but he ran out of runway, so then we move him back and then he continues running, right, for that shot. So next, I want to talk to you about fur and VFX. So the two major challenges in this shot is, number one, fur, of course. Number two is the water. So we have a water sprinkler, so this guy needs to squirt water, right? At first, the team was thinking about maybe doing this in Houdini, exporting out as Olympic cache, and then playing this in Unity, right? But fortunately, at that time, visual effects graph came out, and the team felt that, hey, maybe this can be something that we can use. So then the lead graphics test engineer Vlad lent his talent to create this water effect. So this water was done purely in visual VFX graph. So you can see here, this is working in real time. So it's sort of like a game to test out how the water will look like. So you can just tell, hey, water sprinkler point at this direction and shoot, right? And it works pretty well. And another effects that was used is some subtle effects, like as the raccoon is moving through the bushes, you see like the leaves falling down onto the ground. Or when I think this is the water sprinkler coming out from the ground. So this is also done with visual effect graph. So the visual effects graph team, well, when Vlad involved in the project, he was just supposed to create the water effect, but then there was more requests, and then he stayed on, and the entire shot's visual effects was done by him. But the team got a lot of good feedback from this project, a lot of good real-world kind of issues and workflow, and they can bring it back to the team and improve on the visual effect graph workflow. So yeah, things work out for both parties. And fur. So another major challenge for the shot is fur. And this is also a common question when we talk to animation studios, like, hey, can you do real-time fur, right? So the initial idea wasn't to create real-looking fur, but a more stylized fur. And this was an initial early test of the Raccoon. The initial look of the fur they were going for was something like revolting rhymes, kind of stylized fur. If you have not seen the revolting fur animation, that's a pretty cool one. So yeah, you can achieve good quality offline rendering, but then real-time fur is a real challenge. Okay. So this is an early test of the fur. And when we're talking about fur, there's 4 key elements here. Geometry generation, shading, how would you shade the fur, and dynamics, how can the fur react to physics, right? Maybe when it's wet, how would it react, or what about wind, right? How would it react to wind? And authoring, that's another very important one. How can you let artists easily style your fur? So, so the team tackled the geometry generation and shading, and they experimented with dynamics, but decided to drop it because there wasn't enough time. And authoring was also important, but also maybe something, so for the project, they relied on Mari for authoring the hair, but in the future, they intend to put some kind of tooling into Unity that allows artists to style the fur directly in Unity. But for the project, they use Mari for that. So the basic idea of real-time fur, at least in this project, was to use fur shell. So it's just like multiple layers of the same geometry, and you apply like kind of like transparency to it to create like a stack of geometry to look like fur. So they did some randomization to the surface of the fur. So the surface of the shell. So there is some randomized rotation or positioning, so that it can look more instead of like when you look at the fur at some angle, you would see like this, what you call that, gaps in between, right? But if there's some rotation, you fill up some of the gaps. And another very interesting idea is to bake a mesh, a fur patch created with mesh to SDF, Sign Distance field. So Steve designed this model patch of a fur. So he modeled like individual strands of this fur, and he baked it into a SDF, Sign Distance field. And then this Sign Distance field is then applied to the surface via a shader, and it dictates how the fur shell will behave. What's the normal? What's the direction? How it should start stacking and so on. And the advantage of using a technique like this is now you can have accurate reaction to lighting, to motion vectors, to post-processing effect like motion blur or depth of field. So like I mentioned earlier, for authoring, we rely on Mari for that. So using Mari, we can create like a direction map. So based on that direction map, we can then also style how the fur would react, because you can't have very nice, tidy-looking fur on the Raccoon, right? It doesn't look realistic. And then we relied on screen space, ambient occlusion, and also context shadow to add the small shadows onto the fur to make it look nicer. So for rendering, while working on the project, everything is real time. But when you want to create the final video, the team decided to render at 4K. So they use a render farm, 3 PCs, to render the final video in 4K. But anytime during authoring, you can have on-demand render to see how the final look will, image will look like. So Unity recorders, the recorder tool allows you to export things out from timeline, and you can specify any custom resolution. As far as I know, you can even render up to 8K. So there's a filmic motion blur that the team created for this project. So the idea for this is you dial it up to 11, right? You trade performance for quality. So in this case, because the final outcome is a video, we're not really concerned about performance at runtime, real time. So we're not going to run it at 30 frames per second or 60 frames per second. So we can sacrifice some of the performance, but for higher quality. So for filmic motion blur, we rendered at 960 frames per second to get the blur at 24 frames per second. So while rendering the final frame at 4K, it was going roughly about like 5 frames per second, 5 frames per minute. So yeah, we're trading performance but for quality. And like I mentioned, there's a render window that allows you to see the final look. So here are some interesting facts for the project. When the team started, there was no storyboard, there was no storyline. They just dive right into 3D, put in these characters, and then they start figuring out the story as they go. So they did the layout, right, and then they start playing with the camera, right, start to playing with the characters' positioning, how they want to, whatever, and then they figure out the story as they go. So it can seem like something that's not properly planned, but this gives a lot of freedom to create for the team because you don't have to restrict yourself to like a strict storyboard. You can freely experiment because you can afford that now. You don't have to wait for a lot of the time spent on waiting for rendering or waiting for whatever. It's just there. Everyone can start working and experiment. So the project was created in 2018.4, Unity 2018.4, from concept to final frame. Everything like the fur implementation to the offline render quality stuff. And if you want to give it a try, the project is available, including all the custom package like the filmic motion blur, fur, if I'm not wrong. And you can check out the blog from this link here. And I think there's also 3 very useful videos to show how look depth, lighting composition, and layout was done for this project. And I believe the link to download the project is also in one of these links here, Unity Film Solution, no, in the blog post, sorry, yeah, in the blog post. And finally, thank you for coming to this talk. And I would like you to take some time to fill out the survey to let me know what you think of the talk and also what you think of Unite Singapore so far. You can also take a scan of the QR code, and it should bring you to the link. Thank you. If you have questions, I would like to answer them. Thank you. Yes? Yes.
But in a lot of workflows, the layout artists want to do some basic posing of a character.
Mm-hmm.
See if he's sitting down or pointing his own. So I'm looking for a way, I don't know if you've
So I'm glad you asked that. So the question was, for this project, the layout was simple, like character movements, and camera movements, right? But sometimes artists wants to do some simple poses. So, so is there a way to do some simple IK setup to do simple poses? Yes, we have this new package, and it's called Runtime Rigging. So you can set up like a whole character rig, in fact, in Unity, and you have IK, you have FK, and so on. And Tech is giving a talk later today on runtime rigging. Any other questions? Yep, going once? Yes.
Oh, thanks. Hi. So there was different lighting set up for different shots, right?
Yeah.
So how do you handle the light maps for that?
So for those, like I mentioned earlier, the light maps was only baked for static objects that are not moving, like the houses, right? Those are the big items. And we're only baking the bounce lights. So the direct lightings, those are not baked, so you can still have real time. You can still change them as you go. So only bounce lights are baked.
Okay, hello.
Hi.
Because I'm first time to use Unity, so I'm beginner and not a programmer graduate. Last month, I'm purchased Unity Pro, and it's free for aggregation buried from a memorial. Similar like Sherman, if my team or my game studio modified or reanimate and claim to publish, it's forbidden or it's under Unity license.
So you mean if you take the Sherman project
Yeah.
and you make modification to it,
Yes.
and then you publish it
Yep.
and claim it under your own company, is that okay?
Not my company. Not if we share on social media like Instagram or similar like this.
Yeah. If I'm not wrong, yes. But you should check the terms and condition. But I think the whole purpose of sharing the project out is so that you can learn from the project what the team did and how they did things. And I think you can change stuff, and sharing on social media should be fine. But I'm not legal, so I would suggest you to look at the terms and conditions.
Okay, thank you.
Yeah, thank you. Okay, any other questions? Going once? Going twice? Okay, thank you. I will be always at the expert bar, so if you have any questions or if you have more questions about or you want to see the project, feel free to visit the expert bar. Thank you.